Hello everyone. In our last video we discussed about the force between the charges and the Coulomb's law. We solved some questions related to the force between charges when the charge was on the axis of the two charges and when the charge was on the equatorial plane. In this video we are going to discuss about electric field and electric field strength. So electric field is the space around a charge in which any other charge experiences force. So you can relate electric field with the field of any object. For example, right now my field is just limited to the length of my hand. I can pick anything. For example, I can pick this mobile, I can pick this key, but I cannot pick the things which are kept at the other side of the room without moving from here, because my hand is that much long only. So if I move my hand like this and this hand like this, so there is a range within which I will be able to apply force on any object. So that would be called as my field, provided I'm staying here without moving. So I'm not moving anywhere and I'm staying here, so this is my field. Similarly, charges have their own field, mass has its own field. Now if we take a tiny charge, let's say a positive charge, then this could be the region within which the other charge may experience force. So this is plus Q charge, and here is a test charge, a very small, let's say plus Q charge. So this charge will experience force of repulsion within this region. If I bring this charge somewhere here, this test charge somewhere here, now this test charge is out of the electric field of this plus Q charge kept at the center of the circle. So it will not experience any force. No force. Why no force? Because it's out of the field of this charge. If we take a negative charge, same thing can be said about the negative charge as well. There would be a region within which this charge will apply force on the other charge. Electric field can be represented by electric field lines. In case of negative charge, electric field lines, they point towards the negative charge. Something like this. And in case of positive charges, electric field lines, they point away from the charge. So why do they point away from the charge in case of positive charge, and in case of negative charge they point towards the charge? What is the reason? So the reason is these electric field lines here, here and here, they represent the motion of a positive charge which is kept independent of any other forces within this region or this region, and the only force which is acting on that charge is this electric force or this electric force. The positive charge, if it is kept here, it will move towards the negative charge in a straight line, and if positive charge is kept here, it will move away from this positive charge. Now the next one is electric field strength. So electric field strength helps us to measure how much force will act on a charge if it is kept in the electric field of the another charge. So for example, let's say here is a test charge plus Q kept within the field of this negative charge. So electric field strength at this point will depend on two things. One is the charge of this particle which is kept at the center, and the second thing is the distance of the test charge from the location of the source charge. This is called as source charge because this is the source of electric field. So electric field strength is defined as the force per unit charge in the field of any other charge. So here is this charge, it's experiencing force. So force experienced by this charge divided by the value of this test charge will give you the electric field strength. So here we can write force per unit charge. So electric field is denoted by E, and it's written as E is equal to F by Q. I'm using arrows here. This shows that the electric field is a vector quantity. So unit of E is Newton Coulomb power minus 1.